Okay, so we need to talk about shifting rules.
No.
Okay. No, these are going to be the same shifting rules that you guys know and love from like 4 classes if you've had these. So at this point, I'm assuming you guys know shifting rules, so we're going to go really, really fast. If you don't know shifting rules, say so, and then we'll go slower. Okay, so a standing assumption here is going to be that C is bigger than 0. Cool?
Yeah.
Otherwise, I'll just have to keep saying things like, well, if C is positive, then it'll this, and if C is negative, then it'll that. Right? So I'm just going to assume C is positive, and we'll deal with both plus and minus later. So what's this thing's graph look like?
Whatever f of x is shifted up.
Good. So this is a
Upward shift.
right? F's graph shifted up C units. You guys cool with that? So the way I usually write this is I'll write something along the lines of after the rule add is a shift up. You guys cool with that? So what do I mean after the rule?
We did
After like sine.
Yeah, I mean if you did a bubble diagram for this thing, right?
It's after the function.
Yeah, the bubble diagram would look like you do F first, then you add C, right? So this is the thing that's going to give it its shape. Right, so whatever F looks like, you know, absolute value is a V shape, x squared's a U shape, cubic's got a shape, sine's got a shape, cosine's got a shape. Like you guys know a lot of functions now. So whatever that shape is that you recognize, and then we're going to move it up because we're adding to the y's, right?
Yeah.
We're changing the output so things go up. Cool?
Got it.
What if I did f of x minus c? Down? Cool. I'm not going to write that. I trust you guys can do that. Okay. What other ones are easy? Okay, so after the rule, things are always easier than before the rule. So I'm going to do all the after rule ones. So let's multiply by a constant. So c times f of x. You guys remember this one? Ooh, I need an assumption. So why is it interesting to me whether c is bigger or smaller than 1?
Because that decides whether it goes stretches or compresses.
Yeah, you guys see that? So this is a stretch. You could really think about a number smaller than 1's multiplication as a stretch by something smaller than 1, right? Which means you should smush. I'm going to leave this c bigger than 1 and I'm going to call it a stretch. I'll call the other thing a compression. So if I multiply after the rule, right, then this is going to look like f's graph stretched vertically.
Is there a different word you could use beside that would encompass both compression and stretch, like transformation, or can you not use that word there?
Yeah, you could use other words here.
Kind of helps my brain a little bit.
Sure. Yeah, if you find a good one, let me know.
Pancake or souffle?
So one way you could think about this is just relabeling the y-axis. So for example, right? So like, here's my favorite function to do this with. Here's sine, right? Okay, so normally these are at -1 and 1, right? So this is me thinking of sine of x, right? If I wanted to draw twice sine of x, right, that'd be stretched out. So I could like go through some trouble to draw that. I could like, okay, I'm gonna think about sine of x twice, right? So I'm gonna draw my axes, I'm gonna draw my sine function, and then what's the only difference?
You're gonna just
Just go
relabel
two
it.
higher.
Yeah, I'm gonna call this -2 and that one +2, right? Yeah, so this isn't changing the input things, it's just changing the output, and all it's doing is making one of the old units two of the new ones. So, yeah, you can think about this as a y-axis relabel. So, what if c is smaller than 1? Remember my standing assumption that c is bigger than 0? Yeah, that's a vertical compression. Words hurt? What did I say that hurt you?
Numbers between 0 and 1 are depressing.
No, compressing, not depressing. Cool? You guys good with that? So that would be, again, just a y-axis relabel, right? So if I was going to do half of sine of x, I would just make sine of x, but only half as tall. Or just friggin' slash these into halves, right? The relabel trick is a really good one to know. If you haven't seen that before, I recommend that you pick that one up. What's the other after the rule thing that could happen?
Exponents?
No. These are purely linear things. Otherwise, they change the graph in really unexpected ways. Okay? So, chill things. You're allowed to add and subtract a number. You're allowed to multiply by a number. Yeah, dividing by a number is going to come into here, right? Or here, depending on whether it's bigger or smaller than 1. What else are you allowed to do? Flip the sign. That's it. Those are the only ones you're allowed to do. So, what's minus f of x look like?
It's,
F of x flipped over.
Flipped over the x.
Is there an assumption?
F's graph flipped over
The x-axis.
the x-axis. So I'm going to call that a vertical flip. Can all of you watch this gesture quickly? That's this one. So when I say vertical flip, I mean do a vertical flip, right? Take the top and exchange it for the bottom. Cool? Please note, this is the thing that makes minus x squared things downward pointing parabolas as opposed to upward pointing parabolas, which are kind of the usual. Right? Because they got flipped over someplace in the process. Cool? All right. So these are your after the rule things. After the rule, adding is up, subtracting is down, multiplying by a number bigger than 1 is a vertical stretch, smaller than 1 is a vertical compression, and negative flips things over. Combinations thereof do exactly what you would think they do. Does that make sense?
So multiplying by a negative number smooshes it and then flips it over.
Yeah, so if you're multiplying by -2, it gets stretched out by a factor of 2 and then flipped over. And it doesn't matter whether you flip first or stretch first, all of this stuff, the order is totally fine. Just draw a bubble diagram and you can just apply it from left to right. What's up? You got a thing? No?
I'll just talk about it later.
Cool. Alright, so how about before the rule things?
They're the same.
The x-axis changes.
So yeah, we're going to change the x-axis. So if I do f of x plus or minus c,
It's going to be.
I got to be careful with this one. Let me just do plus because
It's not what you think it does.
yeah. So why am I saying you have to be careful? You guys remember the thing for this?
Because if you add, you go right, and if you minus, you go left.
No.
Oh, backwards. It's
It's
the
it's
exact
opposite.
opposite.
Yeah, so remember, there's no justice in the world at all. So this thing goes backwards from what you would think. So this is a f-scrap shifted, shifted.
Then you could, that's like a formula,
What do you mean?
x minus whatever times, I think a J or K is in there. I can't remember.
Oh yeah, for the trig stuff, there's a whole set of formulas that do phase shifts and amplitude changes and all of this crap. I would really rather if you just knew these because they work with things that aren't trig functions. So this one is f-scrap shifted left. How much?
C.
C. Okay, how would I shift right?
Minus.
Okay, so if I want to shift right C, I should do f of x minus C. Okay, let's see, what else? What's the obvious?
I'll just ask it now.
Okay,
What about, did you do horizontal?
no, I didn't do a horizontal flip yet.
Did you do, flips across the y equals x?
No.
No?
Well, we did that when we did inverse functions.
Yeah.
Yeah, that's not one of these.
Okay.
Thanks.
Mhm.
The horizontal flip is a good one. How would I flip horizontally?
Negative x.
Yeah, I should do f to negative x, right? You guys see why that changes the input things as opposed to the output things?
Yeah.
Okay. So f of negative x is a horizontal flip. And then these ones are sketchy. So again, I'm going to assume c is bigger than 1. So if you do f of c times x, what would you expect this to do?
Just rotate this.
No, that's this one.
Oh, sorry.
I would expect
around
that.
that one.
So if you
it's
multiplied
the
your
horizontals.
inputs by c, you would expect this to do the same thing it does when you do the y's, right? You would expect a stretch. But this compresses things. Again, there's no justice in the world.
Okay.
So this thing is a horizontal
Smush.
smush. Or a horizontal compression. If you wanted a horizontal stretch, what would you need?
X divided by C.
Yeah, you would want to divide x by c. Or multiply by a number smaller than 1. In that case, 1 over c. You guys see that?
Yeah. It's X divided by C, not
So-
C divided by X.
Yeah, x over c. If you divide everything by x, everything will get all screwy. That's not one of the ones we're in. No. So for that one, I'd call it if c is between 0 and 1, right? If it's smaller than 1 in absolute value, then f of c times x is a horizontal stretch. Okay, so all these? Questions, concerns, deals on these? Okay, be really, really careful if there's more than one rule happening or more than one thing happening before the rule. If there is, you have to do everything in the backwards order. It's really a pain in the ass. I recommend you plot a couple points to make sure you got it right. You guys see that? After the rule, you can do as many of these as you want. You just do them in the order that they appear in your bubble diagram. But if you've got a couple before the rule, you have to be really, really careful.
So
Cool.
for like negative f of x, you would flip the x-axis before the rule, and then you'd do f of x, and then if it was f of negative x at the same time, then you'd flip it again.
Yeah, let's talk about those. So let me kill this and we'll chat about